common seen in the movies. Let's say there is a driver driving his car, and he is navigating a turn like this. He navigates. Now what happens is, if this is a top view, then certainly his requirement is mv square upon r. This is the requirement. Centripetal force, centripetal action, because he is moving in a circle, then certainly velocity direction is always changing. Whenever the body is moving in a circle, then centripetal acceleration, it has to be there. When centripetal acceleration it has to be there has to be a centripetal force. There is a requirement of centripetal force. If this body has a mass m, it is moving with a velocity v or speed v, and the radius in which it is, radius of circle in which it is navigating this turn at this instant is r, then at this instant it requires a force, centripetal force, whose value should be mv square upon r. So it is going to look for, that is, who is going to provide me this force. Then the friction force mu mg, this is the limiting value of friction force we know. Mu mg, suppose over here, this can go to, let's say, 100 Newton. Let's say mu mg, the limiting value of friction force is 100 Newton, and at this instant, this requirement is suppose 70 Newton only. So friction force says, good enough, I'll meet your requirement. It's going to be a case of self-adjustment. This will adjust itself to 70 Newton, and this will safely navigate this turn. Now, if this driver increases the speed, then it comes out to be 90 Newton. Still it says, limiting value of friction force says, okay, I will self-adjust myself to 90 Newton and you easily navigate. Now this driver increases the speed to 120 Newton. Friction force says, my limiting value is 100 Newton, I cannot go beyond this. So as a result, when the speed is more, then this slips. When this slips, we have seen that when the speed is high, the car skids outwards. As it skids outwards, then it means R is increasing. When denominator is increasing, this goes down, the requirement goes down, and as soon as this mv square upon r, because now R is increasing, V is more, that's fine. But because now requirement is more, as a result, the car skids. When the car skids, R increases, denominator increases. As a result, when this value comes out to be equal to 100 Newton, this navigates a circle, this navigates a turn in a bigger radius. So, till limiting value of friction force is good enough to meet the requirement, that is centripetal force, this will navigate the circle. But generally at the highways or where there are turns, generally banking of the roads is done. That is, one end of the road is slightly lifted up. Let's say this is, we are looking from the cross section, and this is a car navigating a turn, and this is how the banking has been done at angle theta. This outer edge has been slightly lifted up as compared to this edge which is closer to the center of the circle. This normal reaction represents a normal reaction at both the wheels, and their summation is n. And at this instant, this car of mass m is moving with the speed v, and its radius of circle in which it is taking a turn is radius is r. Now over here, mg is acting in this direction. Mg cannot have a component toward the center. And the requirement, because this is a body of mass m moving with speed v in a circle of radius r, so centripetal force, we know it is going to be mv square upon r. That is, this requirement it has to met if this body it has to move in circle. Now we look out what are forces which are acting on it. The mg cannot have any component towards center, so mg job is done. The only thing is, now let's say n. N can be broken into two components. One is this component, so this is theta. The angle between the two lines and their perpendiculars is same. Perpendicular to this line is this line, and perpendicular to this line is this line. So if this angle is theta, so this is also theta. If this is theta and this is n, so this comes out to be cos component, n cos theta, and this towards center, this component can be broken into two components, this, and this comes out to be n sin theta. If it is moving at a one level only, it is not going up or coming down, it is navigating a circle at one level, so it means n cos theta is equal to mg, and n sin theta meets the requirement of centripetal force mv square upon r. So once again, tan theta is equal to v square upon rg. So now we see that is theta of the road is fixed. It is not, cannot be changed time and again. Once road has been made, theta is fixed, r is fixed, g is fixed. It means this banking is done for a particular value of speed. At this level, if tan theta is equal to v square upon rg, over here for this velocity, he doesn't have to make use of any friction force along this direction. If the driver increases the speed beyond v, then this will have a tendency to skid this way and the friction force will arise in this direction, and component of this friction force, one component of this way, will add to the real force towards center. If we know on highway, generally the people, they shall be driving at so many miles per hour or so many kilometers per hour, and this is the radius, and then certainly that is theta angle, it can be found out, and the road can be banked at that angle.